Hello everyone, welcome to Genera Neura. Have you ever wondered how simple pattern matching in AI works? Traditional AI acts on intuition, generating the next word instantly, but today we are pulling back the curtain on a massive shift, that is cognitive architectures. This isn't just about building smarter models, it's a structural blueprint designed to replicate human like thought processes. Let's break down exactly how it works. We can say that the foundations are sensory processing or sensor processing. Every cognitive cycle begins here. Sensory processing. Before an intelligent system can reason, it has to perceive. This model acts as the AI's digital eyes and ears, gathering raw data, whether it's audio streams, camera feeds, text inputs, or raw environmental logs, and translating it into a unified language the core engine can actually understand. Once the data is in from the digital eyes and ears, that is sensor processing, there comes working memory. Just like humans' short term memory, this acts as a temporary ultra fast storage cache for immediate tasks. If you are having a conversation with an AI, this module holds on to the last few sentences you said, keeping your current goals fresh in its mind without clogging up its permanent databases. After the short term memory, there comes long term memory. But short term context isn't enough. For deep intelligence, you need long term memory. This is a vast structural knowledge base. It stores semantic data, permanent records, past event histories, and foundational rules. When a complex problem arises, the system pulls from this infinite library to back up its logic with hard data. Now, the dual memory systems are in action. The magic happens when these two interact. In a true cognitive architecture, you have a dual memory system in action. The system coordinates your short term focus with long term context. Remember this, short term focus with long term context. It dynamically pulls relevant past expertise into its working context, updates its records, and feeds a clean stream of information straight to the reasoning engine. Now, the next step will be the action selection or decision making. With all the data organized, the architecture enters action selection. This is the decision making hub. Instead of just firing off a random answer, the system weighs its options against simple structured rules. Does it use raw logic, calculate a statistical probability, or lean on a quick heuristic guess? What is a heuristic guess? Heuristic guess, that means a problem solving in a pragmatic manner that should not be compulsorily perfected or optimized. It evaluates these simple paths to pick up the most effective next move. Now, next comes advanced reasoning. What is advanced reasoning? This brings us to the core engine, advanced reasoning. In human psychology, Nobel laureate Daniel Kahneman introduced System 1 and System 2 thinking. System 1 is fast, automatic, and intuitive, like recognizing a face. System 2 is slow, deliberate, and analytical, like solving a complex math problem. Advanced AI reasoning is the transition into System 2 thinking. So, advanced AI reasoning is the transition into System 2 thinking. Now, here comes System 2 thinking, slow and deliberate. When an AI engages System 2 thinking, it consciously slows down. It uses an internal clock. Yes, it uses an internal clock to process complex logic before responding. Instead of shooting from the hip, it allocates computational time to ponder, cross reference its memory, and structurally verify its conclusion before it types or produces a single word. Now, here comes tree of thoughts reasoning. To achieve this, the reasoning engine uses an approach called the tree of thoughts. I would say the chain of thoughts or tree of thoughts. Traditional models think linearly, straight, linearly. A tree of thoughts framework allows the AI to branch out. It explores option A, evaluates it, realizes it, when it realizes it that it has hit a dead end, backtracks to the main trunk and tries plan B or plan C. If the plan A fails, then it tries plan B or plan C. It literally maps out its own thought process. Then the next comes self correction and error handling. Because it maps its own thoughts, The AI unlocks a crucial superpower, self correction. If a piece of code it writes fails an internal test, it doesn't break down. The system built the system is built to identify its own mistakes, handle the error gracefully, revise its internal logic path, and iterate on a better solution entirely on its own. Now comes the unified autonomous agent. When you take a robust cognitive architecture which handles memory and structure and fuse it with advanced reasoning which handles logic and intellect, you get the unified autonomous agent. This is an AI that doesn't need constant prompts. It can break down a massive ambiguous goal, organize its thoughts, and execute complex workflows independently. Now, real world application can be smart assistant. What does this look like in the real world? Imagine a truly unified smart assistant. It acts as the central hub of your digital life, seamlessly managing your smart home, updating your car's navigation based on calendar changes, and organizing your cloud data. It doesn't just react to commands, it proactively adapts to your changing environments and goals in real time. So, as a result, advanced reasoning and cognitive architectures are turning AI from a single simple tool into a true cognitive partner. If you found this breakdown helpful, hit that like button, subscribe for more deep dives into the future of tech, and let me know in the comments what would you build with an autonomous agent. See you in the next video.